If one good thing comes out of this COVID-19 crisis is that probably there will be a lot of demystifying of the role of robots.
Welcome to a brand new episode of our podcast, Human and AI, Mind, Machines, and the Gradient Descent. So thanks for tuning in, and it means the world to us that you're listening to us. We are Kees and Uli, today's moderators, and I would actually like to go and introduce our guest today, which is Juan Aparicio Ojea from Siemens Corporate Technology in Berkeley, California. So his goal is to create intelligent, autonomous industrial machines with a combination of automation, digitalization, and AI. So really deep into the field. He's also awarded the MIT Tech Review, Innovator Under 35 Europe in 2019. So with that said, Juan, could you maybe elaborate on this and describe yourself in 1 minute to say who you are and what you do?
Thank you, Kees. Thank you, Uli, for having me here to make a good high-level introduction. So I could add that in essence, I am a robotics fan, a robotics evangelist, if you want, that has the luck to lead a team of extremely talented automation and AI enthusiasts. I have an amazing team, and with their hard work, we are really trying to revolutionize the world of flexible manufacturing and robotics. And we don't do this alone. We are lucky enough to be part of the innovation ecosystem of Silicon Valley. And we have great partnerships, academia, startups.
All right, Juan. But before we dive into the technology, right? Let's step one back, right? We are somehow in a challenging time, aren't we? Right. And so, if you would choose a song or band or a soundtrack that would somehow reflect your current mood or the current setup, the last couple of weeks, your team and you are into, what would be the music like?
Yeah, I have to choose a song for my favorite band, probably Dire Straits, Brothers in Arms. I think it reflects a little bit how we are all fighting together this common enemy as brothers around the world. It's not a problem that is local, it's a crisis that we are all facing as a world, as a humanity, and step by step we are winning. That's kind of reflecting my...
All right. This crisis, are you referring to the current corona situation? And with that said, actually, I would like to ask you the following. So you're leading the research group on advanced manufacturing automation. And how does this impact you and your team, this current situation? How is that any different for you guys?
So we are people that work a lot with hardware and robots, and we definitely miss our robots. Funny enough, some of my team members have their own robots at home, which is very interesting trend to see on how price of robots are getting low, that even people at their homes can have collaborative robots working with them and doing some tasks at home. So that's very exciting. As obviously, but as I said, not having the access to the physical assets, we are all working from home, and we do as much work as we can on simulation and try to also talk with each other often, use all the platforms that we have that are available to us to keep in touch, right? To still not isolate ourselves. And it's working, right? We feel, even by working from home and not seeing my team day to day, I think we feel closer more than ever. We are having the same problems, the same challenges. We are facing them as a team.
You mentioned the home. At home, you said robots at home. What kind of examples can you give of people having robots at home that aid them in their daily life?
So that is to be honest, it's one of the first use cases of an industrial arm that I have seen really bridging the gap between having it in manufacturing somewhere or in a shop floor and having it at home. I mean, everybody has a lot of people have a Roomba, right? This is from iRobot, deployed robots out there that does some kind of vacuum cleaning. I mean, probably less than what you can expect, but it's still cool for open spaces. I can navigate. Doesn't go up the stairs, so that's where it stops. It's cool. It's interesting to see that while there are a lot of interesting companies popping up in manufacturing or in the autonomous driving space, almost every company that I know, the startup that I try to go into the space of commercial robots, like for homes, they all have failed. It's just very hard, right? The consumers when we deliver a solution to a B2C, to a customer, it has to work all the time, has to be wrapped. And what people have figured out also is that houses are very different to each other, and the environment is not as constrained as in a factory.
Is it also that the Roomba brought you to the field of corporate research, or what brought you actually then in there? Was it consumer goods, or was it always, to make an impact on industrial floor, on the shop floor level, pushing more automation in the manufacturing?
Yeah, it was definitely on the manufacturing side more than the home robotics. So I had the luck a few years ago to got the task from my previous boss. Hey Juan, I want you to design how the factory of the future will look like, and you don't have any constraints. So just yourself, talk with whoever you want in Siemens, outside Siemens, but design the factory of the future. You can use Siemens components or non-Siemens components, anything. So then when I was getting deeper on today's technology, I was realizing, okay, there is a huge opportunity. We have become very good in automating predictable processes that are easy to model. Or when I say easy, it's with all the respect to engineers and mathematicians that create those models, but things that repeat themselves, like I do the same car 1,000 times, so I can automate that. But still, we use humans for anything where you require any flexibility, any dexterity. But that's a huge opportunity, right? That human labor is getting more scarce. Also, the skills of people that can do the job is getting tougher and tougher to find those skills. And we are, linking back to the COVID-19 situation, it's even more accentuated right now that we need more machines working along and enhancing the work of humans. So that was what brought me to the field of automation and robotics. After I designed that factory, if anybody has the luck to go to Princeton, New Jersey, they can see the lab in action. I went to Berkeley in California and continue the work, but in a bigger scope to make this a reality.
So if you think about these achievements in the factory, for instance, and all these other things, and you've mentioned the automation of very simple things has been very helpful in the last years, what would you consider the major breakthrough, or let's say the mind-blowing change, maybe in AI of the last few years? What has been the biggest change for you?
So it's interesting how the field of AI merged with automation, and I can give you my perspective from the robotics world. Definitely what helped was the hype, but also the work around autonomous cars. It's really bootstrapped and started an entire industry. And people realized that with the technologies back then, it's really started, even though there are claims of autonomous cars, very cool videos from technologies from 80s or 90s. We recently discovered that Siemens had the first cleaning robot in the 2000s. That's very cool. Completely autonomous cleaning robot for supermarkets. Developed by Siemens, the first SLAM commercial application in early 2000. But it was too early, right? They decided to stop that. But that's an interesting finding. But to my point, definitely autonomous cars industry exploded, and they realized, okay, we can really achieve this 99% of autonomous driving, but this 1% is taking forever, right? And that's because of a good reason, right? Because the world is completely, there is no structure, right? A kid can jump suddenly and go after a ball. There can be a deer across this street, maybe doing road blocks. The painting may be different, but in manufacturing on the other side, you can constrain the environment, and that's very powerful. So when I started talking with some brilliant minds in robot learning, merging the AI, bringing it to robotics, people like Peter Avil, Ken Goldberg, or Sergey Levin in Berkeley, it was a lot of focus on end-to-end learning and not necessarily on manufacturing. But after collaborating with them, after developing trust and some projects, I think the appetite for manufacturing was always there. And we were able to really bring that research into manufacturing problems where you have, again, it's on the one side, you have to be very precise. You have to be 99.99 precise, but at least you're at the system level. But on the other side, you can, as I said, constrain the environment, and you have the CAD files of almost, the CAD files of almost everything around you. So you can leverage a lot of information, really unleash the power of autonomy.
Yeah, but there is a big of a trend, right, towards end-to-end deep learning aspects, doing everything, end-to-end, at least on the research side, right? From perception to learning to actuation, you want to do it end-to-end, whether it's drone-based or car-based or the bit of, robotics. Though what is your stack, right? Is that something maybe, you have heard also, followed the work of Kapathy, software 3.0, putting everything as a learn challenge, right? Make everything as a learnable challenge, and then an ensemble of basically neural nets forcing towards end-to-end scenarios. Is that also in industrial domain? Is that somehow you follow? Say, yeah.
I would say maybe one day, but may not today, definitely. Not to make an impact in the next 5 years. The interesting thing about the industrial domain is that we have very good controllers, very good old-fashioned control that works very well when you can model your environment. So if you want the robot to go from A to B, why would you throw the robot controller out? Right? Why would you not take into account the carefully crafted controller that came with the to achieve this sub-millimeter precision? But on the other hand, when you are touching something, when you become in contact with the surface, when the contact dynamics come into place, those are very difficult to model. And in those situations, that's where machine learning or data-driven approaches really shine, because you can really leverage the trial and error, reinforcement learning approaches to really learn a policy that you haven't been programmed before. Also for tuning all sorts of parameters and adapt to the wear and tear of the robot, to the self-calibration. Those I'm very optimistic, but not completely end-to-end. It's interesting also how, linking to what I just said, how all these professors, most of them, at least from Peter Birol or Sergey, they started really on the end-to-end learning. But we have really made a difference in our publication, also in our work, since we work together, is on what if we add, for example, knowledge of the CAD file of what you're trying to assemble into the algorithm. Or if you also add a model predictive control approach algorithm, how can you be better? And we have shown that on those scenarios, you can really be much more precise. We even call it residual reinforcement learning approach, where you still have this traditional feedback loop control whenever you can apply it. But then when you are not confident enough, when you don't know the model, that's where you just use your reinforcement learning. I see it more as a toolbox, as having a set of tools in your tool belt. And machine learning is definitely a very powerful that we can use.
Maybe a different question, also concerning your background, is if you would consider the Industrial Revolution, we had the automation of the manual tasks. And right now we have a different revolution going on where we try to kind of automate the cognitive tasks. That's what machine learning is doing. It's taking the things that the cognitive choices we make and automates this. Concerning your background as well, what do you think might be the next big step after this one, the next revolution in robotics or automation or anything? Any ideas of that?
Yes, very, very interesting question, right? As you said very well, right? We automated labor, then we are starting to automate cognitive tasks. What else? Even tasks that we think today require a lot of knowledge are beginning to be automated, like coding or like tuning parameters in machine learning, automating the automation. Also linking to your previous question, what a major breakthrough in the last years that I see is this explosion also on meta learning, right? On self-supervising learning, what Jean LeCun defined as the core of the cake in machine learning, where we can see right now, just going a little bit of describing the algorithm, right? So right now it still takes a lot of time, as you know, to tune parameters in machine learning algorithms. Reinforcement learning, it takes a lot of time to tune those rewards. So what if we can use some meta information to kind of learn to learn, teach the system a way that it can learn? Now, the interesting thing or the limitation is that same than in supervised learning, this is very dependent to distribution in your tests, right? Or test data define a lot, our training data defines a lot. So the next level is really how do you automate the choosing of those tests so you can generalize better and you can maximize learning there. So if you think about that, right, you are giving, just put in a very high level analogy, you are giving robots or systems the capability to design their own tests so they can learn more efficiently. So even tasks that we thought that still learn machine learning because this will be the job of the future. I think definitely there is a lot of value in understanding the fundamentals, the mathematics. This will never get old. But just simply learning tools, tuning parameters, this can be even out shortly. It's not being said that humans will not have a job. Of course not.
But I guess there are two different directions. The one is the pure connectionist. So let's try to push semi-supervised or self-supervision, like unsupervised learning approaches, and we throw enough GPU, throw enough situation, we throw enough data onto that, and we crunch it with effectively machine learning, then we are confident that we can learn all these different aspects and, uncertainty that the world, or mostly all these that we have, right? And on the other side, you have then those aspects saying, no, we need to reach back actually to symbolic learning, right? To the, back to the semantics basically coming again, right? And obviously one would say, yeah, what about, let's choose both weapons, go the way in the middle, right? Choose from the symbolic learning, doing knowledge graph structure, symbolic aspects, and pushing. But how do you combine it? What's your stake, right? Are you considering yourself on the one community or the other? Or how do you see the interface between connectionist and symbolics movement?
Yeah, definitely in the middle. I see value in both. I mean, usually the world is not black and white, right? I mean, if you send a robot to Mars, that robot suddenly break a leg, you really want it to learn how to, or loses a wheel. You really want that robot to learn, no matter what it takes, a new environment. You don't have any time, is not constrained there. Just learn. Use all your tools that you have to learn as a child will. But in the real world, we have a lot of models, and that also comes with explainability, a way to not having this black box that you cannot explain really what is going on. So a mix of both is what really powerful. You learn something new, you try to represent that back in our knowledge, a new node of knowledge. And we are doing also that type of research with professors like Yuri Lesko, Stefano Herman in Stanford. This is really a mix. I mean, the word is Newtonian, right? Why don't you use the laws of physics in your learning force? Really expedite, right? We use that a lot when we want to learn fast. One of the criticisms of reinforcement learning is that it takes, but hey, let's use as much information as we have about the process to accelerate learning, but also to give it some explainability in a lot of cases is important. Even though I also believe that is overrated. So there is it's not like I need to explain everything. I cannot explain also some of the decisions that human people do, right? Just look at what politicians say on the news. Try to explain why. So if I cannot explain why a human take a decision, why I do require the algorithm to do that, I just want it to be safe. And I want the overall system to be safe and give the overall constraints around it so that it's safe. So as I said, the word explainability is probably, the term explainability is overrated, but it's good also to have more knowledge of what is going on in the algorithms and use the power of knowledge graphs or more symbolic approaches, formal methods to really create autonomy. And you don't want just the robot to take their own decisions. This is not what we are trying to do here, not just consciousness in robots. We are trying just so that they can be more flexible, fast and powerful.
Considering what you just said about if humans can explain it, then robots should also not be expected to be able to explain everything. How does this go into the self-driving cars? So right now we have this 1% where we say, well, a lot of the world is unexpected and a lot of weird things happen. But can you expect a self-driving car to never have any kind of accidents? This story about should it make you calculate a choice of either to hit one person or two people, but if you talk about when humans are facing this situation, they would rather hit 5 people at the same time, even if they wouldn't have to. So is this a problem that robots have way too high expectations upon them?
Definitely the autonomous cars is a very interesting use case because they are thrown into a system that wasn't designed for them. Manufacturing, you can design the system for account for autonomy. So if there is an accident, usually the case that a human is doing something that is sudden can guarantee certain levels of safety. But in the real world, it's impossible to account for all the situations that you can see out there, all the mistakes that can happen, writing on the scene app. So that's why I see more in the near future scenarios where either geofence deployment, where they are only deployed in very specific situations where humans are not necessarily interacting or able to interact with autonomous vehicles unless in certain points the human either gets out of the car or if the robots autonomous cars drive really at very low speeds for delivering food, for example. There are some startups trying to that use case. I mean, it's really, if you think about the opportunities, right? It's gonna be able, we have full autonomy. It's gonna really be able to change the life of a lot of people that cannot really drive, particularly countries like the US where there is no public transport. It's just that we are not there yet, and it's very difficult to account for all possibilities on the world and have the ethical and the law framework around to really protect the technology. I think mistakes will be made, and there will be accidents. We just have to, as engineers, make sure that we do our best to ensure that the systems follow the right procedures and that we have the right standards around to have trust in those. At the end, it's that you're trusting your life in a system that can kill you. But the same thing happens when you get in your car, right? The engine can suddenly stop and you're in the middle of a highway. It's just a different level because you don't feel yourself in control. So I see that still those questions are so important that still will take many years to solve. Just the truth to be made right now, as of today, autonomous cars have made zero impact in human life. We have been talking for many years, right? Understanding this really exponential curve from when a technology will be ready is hard. It's a matter of time. There will be a time where cars will be autonomous cars, but it's very difficult to estimate when. And a lot of people have failed in those predictions.
What's your bet? Autonomous cars first or flying cars? What do we see first?
I think the first thing that will come will be autonomous cars, but geofence or with not fully autonomy, but level autonomy. It's very similar to autopilot. You can also argue that already pretty autonomous, but again, also faulty in a lot of situations.
Maybe we can try a lighthearted question, but also a very interesting one. People, the audience, might also know that in 2013 there was a movie that came out called Her, featuring Scarlett Johansson and Joaquin Phoenix. Are you familiar with this movie?
I have heard about that. I haven't seen it.
Okay, so basically in the movie there is it's a futuristic movie about a very smart AI, and there's a love relationship going on from this person who's a human, falling in love with his AI, his artificial intelligence. Do you think, maybe talking about robotics and artificial intelligence, we also know that in I think it's Japan or China, I'm not sure where it was, there's also an increasing trend of companion robots. What is your take on this future of maybe people and robots living side by side? What do you think about it?
Yes, that's a bigger question on how do we really project our fantasies, but also our fears. There is a term now that has been coined by a good friend and collaborator Ken Goldberg and others on robot exotism, on how do we really project our fears and also fantasies into robots, right? And that's part of the sci-fi culture. And as humans' ultimate desire of creating life, right? Extend our thoughts beyond our material living and getting philosophical. But I mean, definitely people get attached, and I focus a lot on the labor side of things, right? On how humans can make people more productive and really remove us from tedious or dangerous tasks. And we are seeing it today with the current COVID crisis. But there is also the aspect of how robots can help humans on more caring tasks. There is a very cool startup that created a robot that is in the form of a puppy, right? A small dog. And that's very useful for people with Alzheimer, with people with child's autism, because they really provide certain comfort. And it's being shown, and there are a lot of studies that really the quality of life really improves. And you cannot, for example, a person with Alzheimer, they cannot have a real dog because they will forget to feed them. But if you have a robot dog, you don't have to eat, and it can bark. It can also provide all sorts of extra sensory capabilities for the human. So I see a lot of potential, also particularly in societies with more older population, Japan, caring provided by robots, care provided by robots also in hospitals. That's a very important dimension, but also keeping into account limitations will not replace the feeling of interacting with a human. If one good thing comes out of this COVID-19 crisis is that probably there will be a lot of demystifying of the role of robots, right?
Maybe you can share a couple of use cases, coming a bit to the end. What are the use cases you've worked on or industrial domain where you're like, oh, that's pretty interesting. That somehow pushed your, motivation up, and see that's awesome. That has an impact on manufacturing.
Thanks for asking. So what I really see is we're working a lot of exciting fronts, but as many also other companies are realizing, one of the holy grail of robotics for a long time was universal grasping, being able to grasp any single object in any shape and form. And we are making a lot of progress to incorporate that piece of technology to manufacturing. First, it all started with our work with Berkeley, with Ken Goldberg, and an algorithm called DexNet, the security network. We have continued working with them and created our own flavor of technology that enable robots to grasp any object on a bin. Still, it's very powerful, but we have to also understand the limitations. But we are already quite fast as a kind of a warehouse or logistic worker could do. If you think about that work right now, I mean, Amazon is required to hire 100,000 people just to keep up with the demand on the fulfillment centers. And that's very difficult when you want to keep social distance. Amazing that a robot could do that work. That is basically moving objects from one place to another. There's a lot of focus on the picking. Placing is equally important. And then you need to also add some constraints. We are also working in the front of assembly, making able robots to assemble electronics, big parts, where you use also reinforcement learning to learn the contacts and be able to assemble two parts together, same thing that humans could do. We are also applying other techniques of AI to industries that haven't been automated at all. For example, garment is a $1 trillion industry that manufacturing of clothes that is mostly manual. We are working with very interesting startups and government agencies to be able to automate that with some components of AI, but also good old-fashioned control systems, the broader term of AI, not only much a broader term, to tackle that problem of automating industries rely completely on human labor. So it's a very, very exciting time to work in the intersection of robotics and AI. I like to say when I look into to hire a new person, right, to a roboticist, and roboticists are like a Renaissance engineer, right? Because they need to know control, they need to know physics, they need to know the math, and now we are throwing them computer vision, you're throwing them software, and you're throwing them machine learning. So the most multidisciplinary branch of engineering that I can think about. And the embodiment is what we really care about. There is a big difference between the kind of machine learning and algorithms that we can do in data science with pure data and what we really transfer into an embodied physical device, the power of autonomy.
Maybe finally, for all geeks out there, right? What is your recommendation? How do you get started in autonomous system in robotics? Are there any people you say that you need to follow, any Twitter accounts, any Udacity or Coursera courses, university rolled out, right? Any resources to share, right? Is there any?
Okay, so yeah, happy to share. For all of those people that are now working from home and they have kids that they need to be entertained, like myself, that I have a 2-year-old. There is a very cool book by the daughter of Ken Goldberg, Bluma Goldberg, called How to Train Your Robot. So you can start infusing some interest about robotics to your youngsters at home. If you want to get into robotics and learn more, I suggest any book on ROS. The robotic operating system is very useful because that also will give you the software flavor of it. And there is a good one by Morgan Kigley called Robots with ROS, Programming Robots with ROS. On the more traditional, I mean, kind of in the one book that should be in every bookshelf of roboticists is this Probabilistic Robotics by Dieter Fox and others. Dieter Fox is also another of our collaborators, now working part-time between University of Washington and NVIDIA. And obviously, I mean, more on the science fiction, I am still a fan of I, Robot by Asimov.
Yeah, let's let the law begin, right? Okay. And for the end, maybe, let me give you a couple of sentence starters or phrases, right? You want to finish up that, right? Play a little ping pong game, okay? Siemens is
170 years old startup, door opener name, and always deliver attitude.
Communication is
being in touch with each other, being sure that your message is delivered and understood.
Purpose is
contributing to something bigger than yourself, transforming into.
My favorite quote is from
Eleanor Roosevelt. The future belongs to those who believe in the beauty of their dreams.
Oh, nice. And last and finally, my personal moonshot is
democratize the access to robotics, enable true flexible manufacturing, logistics, and service that multiply not replace, but multiply human reach.
Visionary. There you go.
Thank you so much, Juan. So for everyone out there listening, stay tuned. There are way more episodes coming your way. So remember to stay bold, committed, and open-minded, and we'll be hearing you here at the same place, the Siemens AI podcast. So thank you everyone for joining in, and that was it for today.